Alright. So up to this point, alright, so today there's not going to be attendance. I'm not going to take attendance. It's not compulsory. It's a replacement class. So try your best to come if you can. Alright, and we have actually finished covering chapter 2 today, this morning. Okay, so by now you should be very familiar with all of those instructions that we use. Okay, and using the instruction set should be a piece of cake right now, and it's something that you should keep using. Alright. So I don't know how many of you saw my post just now. I posted something, a couple of things. Posted the notes. I posted some past year test 1 papers. One of it is with solution, so you can refer to that one with the solution one. The rest, I don't have the solution. So we can discuss them during tutorial or during class, or someone can answer them or post them in the comments and we can discuss there. Okay? Right, if you have time, we'll cover during the tutorial. Okay, and yeah, for information, your midterm is 18. Right. Anyone who cannot make it for the test? Some people have other tests, or you have something else on that day or something. No, right? If you have problems, then come and see me, because we have another session on the same day, but it's in the morning. If you cannot make it, come and see me for that in the morning. Okay. And I've also posted a software. I don't know if you saw my post. So I posted a software. So that software is the software that you are going to see for the rest of the semester. So please download that software and install it on your own laptop. So I really recommend putting it in your own laptop. Don't put it on your friend's laptop or your mom's laptop or any other's laptop. Okay, because you will need to familiarize yourself with this software. Okay? You see this very constantly. And trust me guys, in Micro-P, right, if you don't code yourself, you don't sit down and start typing out this code, you'll be very hard to get the concept. Okay? I can explain to you like 1,000 hours over here, and you don't start typing out yourself, you're still not going to get it. Okay? So I highly recommend you install the software as soon as possible. So after this class, you can start using it already. And I'm going to post another video showing tutorial on how you use the software, how you configure the software and everything. Okay? So you can refer to that tutorial after this. Any question? No. Okay, now today we are going to move on into a new chapter, chapter 3. Okay, so in this chapter is the chapter where we're going to get serious with programming. Okay, don't be afraid. It's not like a C programming. I know C programming kind of sucks. Okay, but this is a bit different from C programming. So hopefully I can make it as interesting as possible for everyone. Okay. If you have any problems throughout this, please voice up and let me know. Okay. So topic 3 is actually a continuation of what we left off. In topic 2, you see fractions of program. Okay, you see fractions of program. So the question you saw in topic 2 was write an instruction to perform a certain things. Okay, but in topic 3 you are going to write an entire program to do that thing. All right. So you will see what is the difference between instructions and a full program. So it has some difference. Okay, if you take your instruction that you wrote in class this morning, put it in the computer, it will give you an error because it's not a full program. Okay, a full program has some templates to it, there's a few stuff to it. Okay, and we're going to cover that in this chapter. And as soon as we cover that, you are going to start typing your program in using the software that I gave you. Okay, so this chapter is really about assembly language programming. Alright, so before we move on to typing out all these codes, there are a bit of structure that you need to understand about assembly language. So think of it like a C language, but this is like a different version of language known as assembly language. Okay, so we have something we call assembler directives. Right, this is like a new term, right? Assembler directive, and this is to use this is used to control the assembler. So I don't want to talk much about this. You will see assembly directive right in the code, okay, in the code itself. And yes, the second thing is assembly instruction. So assembly instruction is what you have been writing down so far. Move FF, add WF, move F. Okay, all those are known as assembly instructions. Okay, this is the second component of the entire structure. Now the third thing is what we call comments. Any idea what's comment? No idea. No idea. Seriously. Comment. You know, in C language, when you write your program, is there a space that you can put your comment? It's like double slash and you can write your comments, right? Okay, maybe some of you remember that, some of you don't. Okay, it turns out in assembly you can do the same thing as well, right? So, what do you think comment is for? Future reference, yes. You think? For your own understanding, correct. Future reference, yes. Anything else? Okay, for others to see, yes. Right, that they are all true. Okay, so these are some very useful things about comment. So imagine you write a code, right? And that code is like just 1,000 lines long. You know, not so long. It's just 1,000 lines. Okay, and yeah. And do you think you can remember every single line, what it does every time you see the program? Okay, maybe if you see it every day, you remember, okay, line number 1 does this, line number 2 does that. Okay, maybe after 5 years, you decided that, okay, I want to improve that program. Do you think you can remember what you did 5 years ago or 10 years ago? Okay, not so likely. Okay, so that is why comment is useful. So comment is just like your own record, or you can take it as a diary of your program. Okay. For example, you write 10 lines of code and then you write comment. Okay, these 10 lines of code actually does this, this, and this. Okay, and 10 years after that, when you refer to your code, oh, you instantly grab the concept. Oh, this 10 line actually does this thing, right? You don't have to crack your head thinking about what it does. That's how comment is useful. Okay, all right. There are some other uses. So, right, that's comment. Okay, so these are the 3 things of a full program. A full program needs to have assembly directive, assembly language instruction, and comment is actually optional, but it's highly recommended that you put comments. Okay, these are components of a full program. All right, so the next thing I'm talking about is columns matter in assembly program. So what do I mean by columns? All right, so for example, you have a program like this. Looks familiar? Move LW, drags 33, drags 40, and LWF. So actually all these instructions, they are divided into columns. Okay, so the way we write it is that we do not start writing our instruction at the first column, but we indent it a little bit inside to be in the second column. Okay, so instructions like move LW, move WF, add WF, move FF, and all the instructions that you have seen so far, they need to start in the second column. So this is like the format of assembly language. And in the software that you're going to use, you need to start from the second column. If you start from the first column, it's going to give you a red color error. So it's like it's a terrible thing. Okay, so start from second column. So these are instructions. So instructions start from the second column, and column 3 onwards, they are known as what? Okay, they are known as operands. Okay, so instruction, in other words, is what we call mnemonics. Okay, anyone knows what mnemonics is? So mnemonics is like a short form of something, right? So for example, add WF, that is actually a mnemonic for add the content of working register and a file. So it's known as add WF. So in other words, all these instructions, they are called mnemonics. Right? So the rest, like all these values that you have, A and F and everything, these are known as operands. Okay? So operands come in from the 3rd, 4th, and 5th column. So after the 3rd column, they are all called operands. Okay, so far so good. Alright. And now, so what is column 1 used for? So column 1 is used for something we call a label. Okay, label. So it turns out that you can label your program. For example, you want to group like 3 lines of code under one name. So you can use a label for that. Okay, so we'll see in detail later on how is a label useful in a program. So a label is something like you're giving a name to this line of code. So in your program, you can say something like go to start from. So the program will instantly jump to this start from. So that is how a label is useful. So you use that a lot in your program. Okay, so that's label. So any questions so far? I think it's quite clear, right? Okay, so next thing is source code. Okay, so anyone ever heard of source code?
Yes.
Okay, source code sounds like a very I don't know, sophisticated word, but source code just means that it's the code that you write on a computer. So if I ask you to write a code on a computer, and I ask you to submit your source code, so source code is that code that you write on a computer. It's known as source code. Okay, so it's the assembly instructions you write on the computer. Alright, and source code contains everything that we have covered just now. There are labels, mnemonics, they have operands, and potentially they have comments. Okay, so these are some of the aspects of source code that you can have. Alright, and one last thing. So how do you separate between column 1, column 2, 3, and 4? Okay, they are separated by hitting the tab button on your computer. Anyone doesn't know where's the tab button located? You don't use that button really often. It's on your left side, towards your left side of the keyboard. Okay, so every time you want to change column, what you do is you hit on the tab button once. So then you jump to the next column, and you hit another one, and you jump to another column. Okay, that's tab button. Okay. Example. Okay, this is an example. All right. So what do you think is this? This column 1 is starting from column 1. So this LOOP. So what do you think is this? Is this a label, mnemonic, or what? So since it starts from column 1, it cannot be mnemonics, cannot be operands. So it should be a label. Okay. So this is like the name. The name for this line of instruction is loop. That's a label. Okay. You can actually give any names you want to the label. Right? But you have to obey a certain rules. A certain characters you cannot use for label. Okay, and a certain characters you can use. Okay, I'll let you know. We'll cover on what characters you can and cannot use later. So the second one is what? So this is the mnemonic, or in other words, it's the instruction. Okay, it can be FWF, MoveF, and etc. Everything that you see in your instruction set, so those are instructions or mnemonics. Alright, so what about this? Operand. Alright, what about this? Okay, this line of programming. Okay, this is a comment. So, how do you write a comment? Okay, this is how you need to start a comment. This symbol is known as what? Semicolon. Okay, so in C programming, semicolon is like the end of every line, right? So in assembly language is different. Semicolon is like the start of every comment. Every starting of comment, you need to have that semicolon. Okay? If you want to write a comment, you need to put a semicolon in front of that comment, right? So that the computer knows that, okay, this is a comment, I'm just going to ignore this line in my execution. Okay? So this is where you write all your descriptions and what you're doing and everything. Okay? Alright, so we're going to talk a little bit about the label field. Yes. The first thing is you must start from column 1. Okay, it's a must. You cannot start label from 2, 3, or 4. You need to start on the first column, and after that you follow by a tab, a space, or a colon, or end of line. Okay. So the rule is like this: it must start with an alphabetic character or an underscore. So what's alphabetic character? 1, 2, 3 is alphabetic. 1, 2, 3 is numeric. Alphabetic is alphabets, A, B, C, D, E, F, G. Okay, you must start with any alphabet, or you can start with the underscore. So can you start with numbers? You cannot start with numbers. Okay, you cannot start a label with numbers. Okay, label like for example, you want to name your label, right? So your label cannot start like this. 5. Okay, this is not a valid label because it starts from a number. Okay, so this is not. So a valid label looks like this. Label 5. So this is okay. And you can start with an underscore. Then you can have 5 label. This is okay. You cannot start with number. You can start with letters, or you can start with an underscore. So that's the rule for label. Okay. So other than that, it may contain alphanumeric characters, underscore, and question marks as well. So alphanumeric character meaning alphabet and numeric. So after you've started your label with the underscore or any alphabet, you can actually insert any alphanumeric characters, any numbers, any alphabets. You can put in underscores, and you can even put in question marks in your labels. Okay? So something like this is valid. Okay. So yeah, and it may contain up to 32 characters. So the longest is 32 characters. Please don't go more than that. So 32 characters is really very long label already. And it is case sensitive by default. So anyone who's not familiar with case sensitive? What do you mean case sensitive? Okay, case sensitive meaning to say is there a difference between capital letter and a small letter? Yes, there is. For example, this and this, they are interpreted as two different labels. Okay, they are not the same thing because this is case sensitive. Alright? Okay, so these are some examples of labels. Okay, so right, the first one is weight. So the name of that label is weight, W-I-T, and then in the second column you continue with the instruction and then your operand and so on. Okay. Second example, you start with an underscore, and this is the name again, and after that you continue with your mnemonics and your operand and and a comment. Okay. All right. So I have a question. Can you write comments in the first column? No. Can. No. Yeah. Can. How do you know? Okay, yeah, comment, yes, the answer is yes. Comments you can write anywhere. Why? Because if you write a comment, that line will be ignored by the computer. Okay, you can write comments anywhere. So as long as you start it with this semicolon, you can start it, you can just put anywhere you like. Okay? The reason is, it's ignored by the computer. Okay? It will not be interpreted by the computer. The computer will just interpret your codes, ignore all your comments. Okay. Alright, so that's about label. So yeah, so we're going to talk about mnemonics next. So it's something that you are already familiar with. So it can be an assembly instruction mnemonic or assembly directive. So we'll see this later. So yes, the important thing about mnemonics is it must begin in column number 2. You cannot begin mnemonics in column number 1. It's reserved for label. Okay. So must be separated label by a colon, okay, or tabs. Okay, this is natural. You separate them with tabs. Okay. Alright, so for example, you have mnemonics of add LW. So the next thing you do to separate the mnemonics from the operand is by hitting the tab. Okay. Alright, but in the software that I've given you, actually the software is not so strict on that. Even if you put a space there, it accepts it. But I would highly recommend you hit a tab instead, right? Because the space will be more obvious, and it's easier to read your program later. Okay. So there's some practice that I do. So yes, it's the same thing. INCF is a mnemonic, and then you have a loop, which is the label there. Okay, so these are some couple of examples. Alright, so this is the second way for you to write labels. So you can also write labels like loop, and then you put a, what is this called? Colon. You put a colon there, and then you start your mnemonics and other stuff. So this is like a second way to write labels. So, right? So the first way is this. You just hit on tab and then it has a space over here and here. This is the second way. You put a colon over there. Okay. Okay, so that's about mnemonics. And operand. Okay. Operand is something that follows mnemonic. Okay, you have seen that. Operand is like your address and your file or register on your access bank. So all those are operands. So it provides instruction, arguments, okay, right? So again, it must be separated from your mnemonics by a tab. Okay, so by a tab. And if you have multiple operands, meaning if you have more than one operands, they are separated by a comma. Okay, so you have seen this, right? At WF, you have specified the address, and then you have a comma, and then W, and then you have a comma again A. So because they have multiple operands, they are separated by a comma, not a tab. Okay, by a comma. Right? For example, like this, move FF. It has two operands, and these two operands are separated by a comma. All right. But the operand and the mnemonics, they are separated by a tab. Okay. So yes, so these are some examples. Yeah. And lastly, comment. So comment is optional. So a comment always starts with a semicolon. So whatever you do, if you want to write comment, put a semicolon at the front. And you can write whatever on that line. Okay, it's only on that line. If you press enter and you go to another line, so you need to put another semicolon. Okay, so every line needs to have a semicolon if you want to write a comment. Okay. And it's totally optional, but it's a very good practice. So I've been programming for a few years right now. Most of the time, good programmers, they tend to put comments in their code, right? Because if you're a good programmer, it is very likely that someone else will read your code. Okay, so that's the thing. So you need to put comments, and yeah. And to be a good programmer yourself, I think it's a good practice to start putting comments because it will help you understand your program more. Okay, sometimes by reading comments, you have an idea, oh, this program actually goes this way, this way. If you don't put comments, you're keeping like a mental model on what your program is doing, right? So every time you arrive at the new line, you're staring at the program. What is like this? Okay, so if you have a comment over there, it's more straightforward. Okay, it helps you think in some ways, right? So it's a very good practice to put comments. So if you start writing program, please put comments if you can. Okay, so as usual, all characters after semicolon is ignored. Alright, and comments provide documentation. Right. So, yeah. So comment may explain a function of a single statement or a group of instructions. So you can use a comment to explain one whole bunch of code, or you can use comment to explain line by line. So every single line you have one comment, one comment, one comment, one comment, like that. Right? So some programmers, they like to sort of copyright their program. So in the comments, they always write, oh, this is my name, and this is when the program is written, and this is what the function of this program. Okay, so yeah, some people do that. Okay, and I think it's also a good practice. So whenever you need to submit your source code to me, please write your names and IDs in your comment so that I know that program belongs to you. Okay. So if everyone has the same file name and they come in to me, I don't know which program is which. Okay, so please put your names and IDs in the comment if you want to submit a source code. Okay. All right. So these are some examples. So are we good? So far is still the boring stuff. We haven't really get into the core of programming. Okay. Can we continue, or do you want to break? Continue. Okay, let's finish earlier. Right. All right. So yes, program structure of the assembly language. So this is the structure of assembly language. So there are a few components. There are something we call assembler directives. So I'll show you what's assembler directive. And there's assembly instruction. There's comments. Now let's look at assembler directive. So you haven't really seen assembler directive so far. Okay, this is the first time that you see assembler directive. And yeah, assembler directive actually consists of a few types. Okay, so these are again these are boring stuff, but I still need to cover this in class, just so that you get a basic understanding. So there are two kinds of assembler directives. They are control, data, listing, macro, objective directives. Okay, we're gonna just briefly skim through some of them. Okay, so control directive. Okay, control directive. Yeah, it's something that you have seen before in your C programming. Do you remember the if-else statement in C programming? Yes. And do you remember how useful it is? Or you hated it so much that you don't care to remember it? Okay, so it's in every programming language that we have right now, you will always have this structure: if-else, 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 if-else. Okay? So because this is how computer thinks. Okay? Computer actually make decisions based on this if-else. Okay? If today is raining, then there's no class. Else there's no rain today, then we have class. Okay? So that is kind of a decision making that we have in computers right now. Okay? So computers think on these rules. They have a set of rules using if-else, if-else, and these rules are determined by humans. Okay? So if-else statement in assembly you have them too. But the way you write if-else in assembly language is a little bit different compared to your C language. Right? In C language, you have all your braces, brackets, and semicolons, and all those messy stuff, right? In assembly language, it's kind of similar. Okay, right? I'll show you in detail later on when we have an example. Okay, so for me, section of conditional example code, okay, is very often used. If-else condition. All right, so this is how you write an if-else condition in assembly language. Okay. So firstly, you have a keyword. There is an if, and then you have after the if you have an expression. So what's an expression? Okay, expression is what you want to detect. Let's say if rain. So you put here rain. If rain, no class. Okay. Else, got class. Okay, that kind of thing. Okay, that's an expression, right? And the one thing that you note is that at the end of the if-else statement, there is something we call as ENDIF. So that signifies the end of the if. Okay. So in C programming, you don't have this end if, right? But you have that curly braces. Okay. So in assembly, that's how you write it. Okay. All right. Okay. So this is a working code on how you use if-else condition. So I say if version equal 1000, and then I want to move LW to X77. Do you understand what it does? Okay, it checks for the version number. If the version number is 1000, then I want to execute this line of code, move LW. So else, if the version is other than 1000, I want to execute another line of code, which is move LW66. Okay. So and at the very end of that if, you have an end if. Okay, very similar. Good. Okay. You need to give me a response. If, otherwise, I thought I would think that wow, I'm going too fast. Okay. Try to give me as much as you can. I'll try to read from everyone as much as I can. Okay. Okay, so there's like a simple question over here. Now, suppose my variable version contains a value of 500. Which instruction you will get to execute? Second one or first one? Second one. Okay. If my version is 500, it won't execute this one. So this line is only executed when version is 1000. Okay. This is an example. So if the version is 500, then I'll execute the second one. Okay. So those are some rules. So you can imagine in a computer, right? In your computer right now, you have like thousands of if-else, 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 if-else kind of things. Okay? For example, you have like your button, if you press A, it needs to display A. Press B, it needs to display B. Okay? So those are some of the rules. And there are a lot of rules in your computer. Okay? It's a complex thing. It's called if-else. Okay, that's the end of if-else. So we're moving on. Yeah. So hope everyone is still alive. Okay. So our next directive is known as the while expression. So while expression. So while is also something that you have seen in your C programming, right? So you have a while, and at the end of it, you have a, instead of end if, you have an end W. So it shows that, okay, it's the end of the while loop. Okay? And you have an expression here. So it's a while loop, and example of a while loop is like this. While I less than 100, and then you execute move LW I. Keep on executing this until you have that value of I goes beyond 100. So it's very simple. You have a while, and then you have NW. Cool? Okay, so N directive. So this is also another control directive. It's known as the N, END. So where do you write this? At the end of the program. Okay, it's so obvious. So it indicates the end of a program. So basically, at the end of the program, you have this thing. You have this thing at the end of the program. So if you don't put this directive at the most bottom of your program, you get an error. The program wouldn't compile. Right? So yeah, for example, okay, we take the if-else example just now. And let's say that is the last piece of code in your program. And before you finish off everything, you need to put an END over there. And okay, next is define. So define is used to so much distraction outside. Okay, so define is actually when you need to define some text or substitution of a string or something, you need to use this directive. So it's known as this hashtag define. So hashtag define. Okay, it's not your Instagram. So it's hashtag define. So it's like hashtag define and then you define something behind it. So example, okay. Let's say you want to define length to be 0x20. So you do hashtag define and then you define the length is 0x20. Okay? So the next time you use your instruction, move LW, you don't have to actually specify 0x20 in your instruction. You can just use this name, length. Okay? So that's how you define things. Use hashtag define. Very simple. Okay? So you can start to define things in your Instagram. Okay, no. Okay? Yeah. So one simple question here. If I do this two instruction, if I have this two instruction, what do you think the value that is loaded in your working register? So it will be 0x20 because you define 0x20 to be length. Okay? Alright, and these are some other examples here. So in this case, you define, okay, you can even do this, right? You can do hashtag define and then you put a name there. The name is config. And now config consists of actually three things, 0x17, F, and 8. Okay, so you define config to be like this three bunch of operands. Now the next thing you do is, let's say you have an @wf, and then you're lazy to write all these 0x17, F8, you can just write config, and it takes care of everything. Okay, so it's like a short form kind of thing. So it's very useful when it is when you need to write something repetitively. The same thing, you need to write it again and again and again, and you are lazy to do copy and paste. You can just define it to one long thing to be a one short name like this. So this is an example of that. Okay, so you're using a common name to define things. So can you think of any other useful things? I mean, useful case of using define. Okay, so over here is useful for renaming stuff, right? So for example, the number 0x20 won't really stick in your mind, right? So there are other numbers as well. So 0x20 does not make any significant difference. But you will rename 0x20 if you rename this variable into something meaningful, for example, length, or some meaningful names. So this variable you tend to remember it better, okay? And you tend to remember what it does, and you tend to remember what it represents, okay? For example, if I rename this 0x20 into length, so I kind of remember, oh, this is actually the length of my certain parameter, certain variable. Okay? So you can actually rename stuff into more meaningful names. Okay, so that is define. Okay, yeah, the next thing is we have include, hashtag include. Hashtag include. Okay. So don't start Instagramming and hashtag define, hashtag include stuff. Okay. Okay. So it's hashtag include. Okay. So what does hashtag include do? So right, it includes an additional source file. Okay. So I think you have seen this in C programming, right? At the very beginning of your program, you have include some file, include some library, include some kind of thing. So, for example, you want your code here uses some library that someone else has written. You want to import that library into your code. So this is what you use, hashtag include. Okay. So it includes additional source file in your program. So other source file, you want that source file to be available in your program. This is what you use, hashtag include. Example, yes. Hashtag include, and then I have lcd_util.asm. So this is like a library name. And can you guess what this library does? So it's an LCD library. Okay. So someone has written a library to actually write on an LCD screen. So you don't want to rewrite everything that person has written, right? So what you do is just include the source file of that programmer, and then you can start using whatever he has written in that source file. Okay? With one condition, you need to do this, hashtag include and include the source file. Alright? So, yeah, and in PIC you often see this, hashtag include, and then you have P18F8680.inc. Okay. So this, don't worry, this is just a cheap number. Okay, so P18 stands for PIC18, and then the number here is the series or the model, which specific model is that. Okay, and the .inc is actually the extension for library files, for PIC library files. Okay, so you will see this a lot. Don't worry. All right, so still okay? Still standing? Okay. So next is radix. Radix. So what do you think this radix does? Okay, just show the answer. Okay, it stands for radix. So in your program or in your source code, there is something we call default radix. So default radix is useful when, for example, you have a command like this: move LW7. So how do you interpret this? Okay, now if your default radix is hex, this move LW7 is actually hex 7. Okay, if your default radix is decimal, so this is decimal 7. Okay, so that's how you specify your default radix. So how do you actually write this? Okay, so it's like that. You write the radix keyword and then you specify the radix. DEC stands for decimal, and if you have hex, it's HEX. But normally, if you have a default radix of hex, you don't need to write anything because by default it is hex. Unless you need to change it to decimal, then you write it. Okay, it says default to decimal. Default radix decimal. So if you do radix decimal and then you start writing this, this is going to be interpreted as a decimal 7. Okay, yeah. Okay, so we reached the end of control directive. Okay, so control directive controls your program flow, if, else, while, define, everything. So the next kind of directive is known as data directive, and data directive is it looks like this. Okay, one of it is known as EQU, equivalent. So equivalent is also useful when you need to define a constant. For example, okay, true EQ1, false EQ0. Okay, so after you have defined these things, you can start using these things that you have defined. So if value is true, move LW0x01. So instead of writing if value equals 1, you can write if value equals true. Okay, it's kind of similar like the one we see just now. What was that? Define? Yeah, it's kind of similar to that. Okay, but this is the different directive. Okay, So it's like giving names to your variable kind of thing. Okay, and the next one is set. So set is something very, very similar to EQ. It's very similar. Instead of using set, EQ, you can also use set. Okay, so functionally it's the same as EQ. So you have actually option to use whichever you like. So set and EQ. Okay, so far so good. Okay, so that is all for data directive. Actually, there are a couple more directives, but I don't want to cover all because you won't really see every single one of them. Okay, so in the event we encounter one directive that we haven't covered in class, so I will go into detail on that. Okay. So I'm just going through the important ones, the things that you will see the most. Okay. So the next kind of directive is macro directive. So macro, what's a macro? So yeah, as what is written here. So macro is actually a group of instructions grouped together under one single name. Okay, for example, you can have a group of instruction that is like 10 line longs, and you want to give that group of instruction a name. So what you do is you make that group of instructions a macro. Okay, it's something like defining a function in C programming. Remember how you define a function? No, okay, good, no problem. Okay, so you don't have to remember that. So macro is something like that. You're grouping instructions together and giving it a name. Okay, to make sure you can easily refer later on to that group of instructions. Okay, so yes, one important thing about macro is a macro can take in an input and it can give an output. So that input that goes into the macro, it is also called argument. Okay? Don't be shocked if you see this word argument. It's not about fighting or arguing or something. So argument meaning is input. So input to your macro. Okay? So you can have argument 1, argument 2, argument 3. So these are 3 arguments to your macro. Okay? Right? Good. So one macro can have more arguments, one or more arguments, or you can even have macro that has no arguments. Okay. So this is an example. All right. So look very, very closely. All right. So look very closely. So I have just defined a group of instructions to be a macro. Okay. So as you know, macro has a name, right? So the name of this macro is 1 underscore plus underscore 2. So after that name, I'm going to write this word, keyword of macro over here. And under that macro is where your instruction is going to be written. Okay? And yeah, one thing about macro is at the end of it, you need to have end M. So end M signifies the end of the macro instruction. So all your instructions that you want to group needs to be in between these 2 lines. This macro and this end M. Okay? So how do you use macro? How do you use macro? So the usage is something like this. So every time in your program you type in 1 underscore plus underscore 2, the computer is actually smart enough to know that, oh, that's actually these 2 lines of code. Okay? So imagine you have a macro that is 100 lines, right? You don't want to like copy paste 100 lines every single time. So you put it under a macro, give it a silly name, and then you remember that silly name. So every time you want that function to do, so just remember that silly name and you get your things done. So grouping instructions together. Okay? Macro. Okay, so in this case, what's the argument to this macro? Argument? Is there an argument to this macro? You're going to fight with this macro? Alright, so there's no argument to this macro. Okay? So how do I know there's no argument? There's nothing over here. If there's argument, meaning after this keyword over here, there should be some things going on here. Right? So instead that this is a comment, okay. This macro has no arguments. Okay? Alright, we're going to take a look at a macro that has arguments. For example, like this. Okay? So this is a macro, and the name of this macro is sum underscore of underscore 3. And I write a macro keyword here. And after this keyword, I specify 3 arguments. Or in other words, 3 inputs or 3 information that I need for this macro. Okay? So, and these arguments are going to be used in different ways. Alright? So, you have argument 1, comma, argument 2, comma, argument 3. So, what's going to happen to this argument? So, argument 1 is going to get moved into the working register. That's argument 1. Argument 1 is going to be transferred to the working register. And argument 2 is going to be added with argument 1 by using this command. Add WF, you're going to add argument 2 and argument 1. Of course, that you're adding the content, right? You're not adding the address. And argument 3, again, is going to be added with the working register as well. Okay? So, take your time to see this. At the end of the day, what happens? Argument 1, argument 2, and argument 3, they're all going to be added. Okay? But is there anything strange that you notice over here? Is there anything strange? Is there anything strange? Okay, argument 1 is actually a content or address. Argument 1 is a content, right? Because argument 1 is the value that's going to go into the working register. Because you mentioned that move LW argument 1, so argument 1 is going to be treated as a content. Whereas argument 2 and argument 3, they are going to be treated as an address, because this is where you put argument 2 and this is where you put argument 3. And you know very well that for this instruction, this position is the position of the address. It's not the position of the content, right? So anytime I want this group of functions to happen, all I need to do is write the name sum of 3 and I specify all the arguments that it needs to have. And just like magic, it computes everything with one line, like this. So otherwise, you will need to always have this 3 line, copy paste, copy paste, copy paste, and your code will end up looking very, very messy. Okay, and it's hard to trace later on. All right, so this is some useful use of macro. So you'll see more later on in class on how else you use macro. Okay. Are we still okay? Good. What's the time now? I wonder. 9. We started at 8:30, right? Okay, don't worry, I'm not going to go beyond 9:30. Okay, so just bear with me a little bit more. This is theory, but I understand that it can be a little bit boring. To me, it's also boring. But this is like the fundamentals of this. If you don't go through this, it's hard for me to explain much more advanced concept. So advanced concept will all build on all this theory fundamentals. Okay, so just bear with me a little bit more. So, do you want a break? You want a break? Okay. No? Yes? Okay, brief one, 2 minutes. Okay? 2 minutes. Okay, just maybe stretch yourself or something. So if you have any question, you can just, any doubt? Yeah? Yeah, why is the location? Yeah, right. So you don't specify value, you specify the address. You're actually moving a content into the working register, and then you're taking a file with the address argument 2, and you add in this content. And then you're taking a file with the address argument 2, and you're adding with 2 and not. Okay? So, now it's useful to draw this as a diagram. I've been getting questions from our friend here who was actually not so clear. I think many of you are not so clear as well on what this macro does. Okay, so when you mention this move LW argument 1, right? So argument 1 is what? 0x20. Right? Argument 1 is 0x20, right? So what's going to happen is that it's going to load argument 1 into working register. You have a working register, and you're going to load argument 1 inside. So argument 1 is what? Argument 1 is 0x20. So in other words, 0x20 is going to be inside there. So that is argument 1. What about this? Add WF argument 2 WF8. So add WF is going to add the address of argument 2 with the working register. So what it's doing is that it's going to take the address of argument 2. Argument 2 is what? 0x30. So it's actually 0x30 over here. Right? 0x30. It's going to take 0x30, and then you're going to add the content of 0x30 with working register. You have no idea what this content is. Okay? So that is what this line does. Add WF, argument 2. So that's why I'm saying argument 2 is actually an address. And argument 1 is actually a content. Okay? The same thing with argument 3. So if you do add WF with argument 3, so what is going to happen is that argument 3 is actually 0x40, and 0x40 goes here. Right? So add WF, 0x40, W. So 0x40 is actually address. Okay? What the content of 0x40 is, we have no idea. So at the end of the day, what's going to happen is 0x20 you're going to add with some content we don't know, but the address is this, and you're going to add again with some content we don't know, but the address is this. So this is what this macro is. Okay, can we continue? Okay, so guys, you can eat or drink or in the class. I have no issues with that. Okay, but make sure you do not distract your friends beside or me. Okay, if you distract me, then I have to share with you. Okay. So are we clear on this macro? Okay, now we're gonna move on. Right? Let's do this as quick as possible. All right. Oh yes, we're gonna go to the concept of flowchart. So that's something very interesting. Okay, so in programming, I believe you have seen this word, right? Flowchart, and you have tried drawing a flowchart. Okay, yes, maybe no, or maybe some of you don't care or forgotten. Okay, in programming, you cannot run away from flowchart. Right, you cannot run away from flowchart because flowchart is like what? It's like your game plan. It's your strategy. It's the way you plan to execute your stuff. Okay, so normally people don't just go to the computers, sit down and start writing code, especially if the code is super complex. So you start breaking down concepts first. Okay, the first step is this, the second step is this, the third step is this. Okay, so we're going to tackle the first step first. Alright, I believe we did this in tutorial, right? We translated like English language into assembly language. Okay, so flowchart is something like that. You are translating your thoughts in your mind to some diagram, and after that you translate that diagram into code. Okay, so this makes your code more systematic, and especially if your program is complex, right? But for simple programs, maybe you don't have to, you don't need a flowchart for a simple program. Okay, so I'm just going to talk a little bit on this concept of flowchart. So how do you draw a flowchart, and what does a flowchart looks like? Okay. Now, okay, so there are a few kinds of boxes in flowcharts. Okay, so these boxes mean different things, yeah? So, right? They all mean different things. So, for example, this box meaning it's a terminal. Terminal meaning to say it's the end box or it's a starting box. Okay, for a start, you need to use this box. For end, you also need to use this box, and the shape is a bit like this. It's kind of a rounded and rectangle. Okay, and this box is the process box. So anytime you have some process, you need to use this rectangle box to show that it's a process. Okay, we'll go through one very interesting example later. And yeah, when you have this kind of box, it's an input or output box. Okay, input or output box. And yeah, most importantly, this kind of box, in this diamond-shaped box, is what we call a decision box. So whenever you need to make a decision, you need to use this kind of box. Okay, this kind of shape. So you have like decision, you either have yes or no. So normally decision is only yes or no. Okay, so if yes, you go to some other place. If no, you lead to some other place. Okay, so this is the decision box. Okay, so alright, decision box is this. What about this? This small circle here is what we call an on-page connector. So what's an on-page connector? So it's actually some connection, but that connection is on the same page. Okay, so it sounds silly, right? So for example here, I have a decision, and if the decision is yes, I'm going to go to A. But where is A? A is on the same page. Here. It needs to be on the same page. Okay, that's why it's known as on-page connector. So I don't have to draw like a line over here like this to connect it to A. But this already shows that it's connected. A is A. And I can continue my arrows over here. A and okay. And this is a subroutine box. So whenever you have a subroutine, use this kind of box. So maybe you cannot see it from the back, but subroutine box is actually like this. There's a this is a subroutine box. It's different from the process box. You have so what's a subroutine? Okay, we'll cover this later. You see what is the subroutine in later classes. Okay, so this is a subroutine box, and what about this box? B. So B is what we call an off-page connector box. So it's like you want to connect to a different flow or different part of the program, but that part is not on the same page. It's on a different page. That's why it's called off-page connector. So this is B, right? So if I go to the next place, yeah, you can have B on the next page. Okay. So, understand what's the difference and how do we use? Okay, I'm going to show you an example. So, this is a simple program, and this program actually decides on whether or not I should go to Microprocessor class on Monday morning. So, this is a program. I'm going to write this program. This program is going to decide for me whether or not I should go to Microprocessor class. Okay, look how this program starts. So, it starts with this box, start, right? So, that start box, remember? You have a rounded end like this. This is the start of the program. So that's the start. So after start, you have like an arrow. Okay, now you come to a box. And this box is a diamond box. And it's a decision box. So this is where you have to make decision. So normally, in these diamond boxes, you have a question inside. You have a question inside. For example, this question here is wake at 8 a.m. So I need to ask, am I awake at 8 a.m.? So that's the decision I need to make. Am I awake? Yes. Or am I not awake? No. There's two answers to this, right? So this is a decision box. So if no is my answer, so I go back and ask the same question. Keep on asking no. Wait, no. No. So you keep on, you're stuck in this loop forever. Okay? So, and you'll be so happy. Okay, no. So you just keep answering no every time. Okay? That's no. Okay, what about yes? Okay, let's say I'm awake at 8 a.m. So what should I do? So, I make another decision. So, another box. Is the weather too good to wake up? Is the weather too good to wake up? So, I make another decision here. Okay, so it can be two answers, right? Yes or no?
No.
Okay, so if yes is the answer, then, okay. Weather is too good, right? Okay, just go sleep. I just don't care. Weather is too good. For example, today evening, weather is too good, right? So just go back to sleep. Okay, if the weather is not so good, then the answer is no, right? So no, then what happens? Continue to sleep in class. Okay, so you still get to sleep. Okay, so this is decision box. I'm just trying to illustrate how to use a decision box, right? So decision box needs to make a decision, and you need to have yes and no. You need to label which is yes and which is no. Okay, so clear? All right, next. And yeah, end. So remember, each flowchart needs to have a start and end. So if you haven't noticed, start and end is the same shape. So it's like a weird rounded edge rectangle. Okay, so this is my program to go to class on Monday morning. Okay, last semester we happened to have a class at 8 a.m. Monday morning, 2 hours. So I made this program for that. Okay. Okay, this is another program, all right? So this program says, should we have tutorial class tomorrow? Okay, I don't know. It depends on the program. Okay, so yeah, so how do you start? Okay, you have a start box. Yes, we good. Start box. Always there. Well, start and end. Oh, this is the best program. It's a good program. Okay, so we conduct Thursday class. Okay, today is the Wednesday class. So we conduct class, and so this is what box? Process. It's a process box, right? So we conduct a class, and that's a process. So it's a process. Now, so in a process, after a process, you go on to the next one, and you have a decision box, and that decision box says what? Class attendance good? No, good or not good? Is it good? Yes or no? There's two answers to this, right? So, yes or no? Okay. Oh, if it's a no, then what happens? You go to some other page. What? This. It's an off-page connector. So that's a surprise, right? You don't know. Keep in mind the answer is no. Okay. But if it's a yes, if class attendance is good, so what's going to happen? Oh, will I have a Friday blue tomorrow? Okay, let's say tomorrow's Friday. Okay, this is last semester's class. They have a Friday class. So I will ask a question. This is me. So will I have Friday blue tomorrow? So I ask this question to myself. I need to make a decision. No. So if I don't have Friday's blue, and if the class attendance is good, okay, we'll conduct a tutorial class. Okay. So on the other hand, if the decision is okay, that's N over there, and yeah, we have this decision. You have no, and you have one more, right? You have a yes. If I happen to have a Friday blue tomorrow or a Thursday blue tomorrow, so you go to B. So what's B? B is an on-page connector. So B is over here. So what B does is send email to cancel class. If I have right. Okay, so this is it's an on-page connector. All right, are we done? No. So we have one more right over there. So that's A. So A is an off-page connector. It cannot be on the same page, right? It's going to be a surprise page, next page. Okay. Okay, A. This is A. So this is off-page connector. This is the next page. So you need to have these arrows like this, and okay, A is to conduct a surprise quiz tomorrow. Okay. So to think about it carefully, whether or not you want to come to class tomorrow, and okay. So this box is a what kind of a box is this? This is a subroutine box. Subroutine box. A subroutine is something like a process as well. Okay, it's kind of similar like a process, but it has like these two lines here, right? Subroutine box and N. Okay. Yep, process. Subroutine box, you have these two lines.
I'm not when to use it.
When to use it? It's actually quite vague between subroutine and process. So a process can be a subroutine. A process can not be a subroutine. So it's actually not that strict. So you can use this. If you're unsure, just use this square box. Okay. So that is all about flowcharts that you need to know. Okay. All the shapes, all the difference, all the arrows and everything. Okay, that's all about flowchart. Okay, so the next time you need to write a complicated program, start with a flowchart. Start with the flowchart, and then you see how the program flows. Okay. All right. Yeah, that's the end of our program. Okay. Any problem? No. Okay. So now we're going to get serious with writing program. We are really going to start writing. Okay, so as I said earlier, right? So far in class, we have seen only like a small portion of a program. We haven't really write a full program. So this is what a full program would look like. And a full program has something we call as a template. So you have a template, and then you put your program inside this template. Okay. So what does this template look like? So it looks like this. Okay. So it's a bit small. I'll move it back. All right. So every program needs to have these few lines of code because this is the template, and I expect you to remember this template. Okay. You actually don't have to purposely remember it. Every time you type out on a computer, it will automatically register in your mind. Okay. So you need to do it often enough so that you don't have to purposely remember all this stuff. All right. So yeah. So for example, this one, you have your hashtag include. Remember what hashtag include is? Includes a library, right? So you want to include a library of PIC18 F4550.inc. So this is the format. Every time you have this inc. Okay. The number over here it actually varies. So it depends on what PIC are you using. You are using PIC18, PIC20, PIC70, PIC1000. I don't know. So it's different. So in this course, we'll be using PIC18, but this number here will change. Alright, so that's the first line. Now, let's take a look at this line, these few lines. So you have org 0x00. So org meaning it's origin. So it's like setting the origin to 0, 0. So setting what to the origin? Setting the program counter. Okay? You want to set the program counter to make sure that it's at the 0 address. That's the first address. You don't want your program counter to be somewhere, nowhere, and then you start running your program. So whenever you want to start to run your program, you want to make sure that your program counter is at 0, 0, which is the most top address, the first address. So this is what org00 does. Okay? And go to start meaning it's going to go to, meaning go to the start. Let's start. Start is down here. Okay, so start is a label. So go to start over here. So it will jump over here. And okay, so it will jump over here and you will start to execute your program. So this is where you put your program after this start label. So in my case, my program is what? NOP. So this is my program. So this program will do NOP. So NOP does what? NOP does nothing. NOP means no operation. So this program does nothing. So it's going to do NOP and then end the program. Okay. So this is how your template looks like. Any question? Any question to this? ORG 008? Okay. So I'm just going to talk about this briefly because these 4 lines they are actually reserved. Okay, it's not 4 lines. These 2 lines, address 0x08 and address 0x18, they are actually reserved for a special purpose. Okay, these are reserved address for a special purpose. And this special purpose is known as the interrupt. We reserve this address for something we call interrupt. So I'm not going to talk about interrupt. Okay, we'll talk about it sometime in the future. Okay, we'll talk about interrupt later. So yeah, these 4 lines are reserved for that. Okay, so don't have to worry about these 4 lines, but this 4 line needs to be there every time you write a program. Okay, this whole thing needs to be there. So whenever you want to write your moveFF, where do you write the moveFF? Say I want to write my program, and my program is move file from 0x10 to 0x11. So where do I write my moveFF? Okay, after this start, right? So I can cancel out this knob and then start my move FF over here. 0x10, 0x11. And just like that, you have written a full program, a running program, to move contents from 10 to 11. And if you key in this program into the software that I have sent to you, it will work, it will run. Okay? Any thoughts? Any doubts? Okay? Template of writing. So yeah, I recommend typing this template in your computer every time. Typing it yourself, not copying and paste. Okay, there's a reason to this. There's a reason why I don't want you to copy and paste. Copy and paste is good. Actually, codes are meant to copy and paste. But when you start to code, it's not so good to copy and paste because otherwise you won't really remember the pieces of code like this. All these details you won't get to really remember it. Okay, so try to type as much as you can. So until you can take it, then you just copy and paste. Okay, but it's not too many lines over here. So as you type, you will remember. Right? This is true. Okay, so now we're going to take a look at a full program for an addition operation. So this is what that program looks like. So as usual, you have include, and then you have all these templates over here, and you have your start over here, and this is where your program goes in. Alright, you have move F and address 0x20 WA, and after that you have your familiar add WF, and after that NOP, NOP, and N. So that NOP doesn't necessarily need to be there. Even if you have NOP, that's fine. But N needs to be there. So, okay, N needs to be there. This N, this is a directive. Okay, so everyone clear? All right. So go back, install the software, and you can start writing down all this code. Okay, case issue. Oh, sorry, there's some issue over here to talk about. It's a case issue. So what's case issue? Isn't an issue a case? Oh. Okay, what's case issue? Okay, it's about the uppercase or lowercase. Alright, that's why it's called a case issue. So I talked about this in class. Is there any difference if you write it uppercase or lowercase? So, is there any difference? Yes. Okay, what about labels then? We talked about labels, right? For labels, yes, it matters. For labels, it matters. Labels with uppercase and labels with lowercase is different, right? But for instructions, mnemonics and the operands, it doesn't matter. Okay, but for labels, just bear in mind, labels are different. Labels are case sensitive. For the rest, it's not. Okay. All right. So, okay, this is our boring stuff. Okay, so there's a little standard that we use over here. So we tend to write special function register. For example, working register, status register, bank, A, or all this kind of special thing we tend to write in uppercase. Okay? Haven't you noticed? I always write working register in uppercase. Okay, so this is like a standard that we use. So if possible, just stick to this standard so that we don't confuse each other at the end of the day. Okay, so special function register like working register, status, bank, and all these operands. So put it in uppercase. Well, it's not wrong if you put it in lowercase. You will still get your program running, but it's just a standard that we use. Okay, so yeah, so we'll use the following convention or the following standard. All mnemonics we'll write it in lowercase, and directives and other special function registers will use the uppercase. So that's how we are going to stick the standard that we're going to stick to for the rest of the semester. Okay. Yeah, for example, this move FF working register 0xDE. Okay, something like this. This lowercase one is the mnemonics, and working register is a special function register. So I want to write it in capital. And this 0xDE, I also want to write in capital. Okay, so it's easier to see this way. Okay. All right, so we're done about case issue. Now another issue. So this is the second issue. This is what we call by order issue. So is it time? Is it time? 9:20. Okay, last thing we'll talk about this. Okay, last issue. Promise, last issue. Won't be other issues after this. Okay, by order issue, right? So we have case issue, and this is our second issue with this program. So many issues. Okay, so this concerns how many bytes are stored for a multi-byte number. Oh, so confusing. I don't know what it talks about. Okay, so yes. So there's actually, I don't know if you've heard of this big endian method. And there's actually two ways to store data, right? It's known as a big endian method and a little endian method. Okay, so yeah, what's the difference? Okay, what's the difference? So the difference is the sequence you store it. So yeah, so we are going to stick to little endian method. Okay, so I hope I have an example. How is a big endian differ from the little endian? So okay, now example is like this. Suppose we have a data, and this data is 0x1, 2, 3, 4, 5, 6, 7, 8. So long. Data so long. How do you want to store this kind of data in the PIC18? Remember, one box in PIC18 can only accommodate how many? 8 bits. 8 bits of data. But this is how many bits? So many bits. It's more than 8 bits, right? 8 bits is like 2 digits of this. So this is like 1, 2, 3, 4, 5, 6, 7. That's 8 digits over here. Okay, so how many bits over here? So how are we going to store this data? So 32 bits number. 32? No, I think it's more than 32. Yeah. So it's not possible to put everything into one box, right? The box is going to overflow. It's going to explode. Okay, not explode. Okay, that box can only fit so much, right? It's not possible to just squeeze everything and put into one register. So we need to use a strategy, and we need to divide this thing up and store it in different boxes. Okay, so yeah, one register can store 8 bits, right? All right, it's something like this. You have a box that is this big, and your data is so long. So yeah, we have to split the number. Okay, so we split them into portions of 8 bits, 8 bits, 8 bits, and 8 bits. Okay, split them into portion of 8 bits like this. Okay, so this is the big endian method. So this is your data just now, 1, 2, 3, 4, 5, 6, 7, 8. So we are going to split them into 8 bits, which is like this, right? So this is 8 bits, right? 8 bits, 8 bits, 8 bits, and 8 bits. So we're going to split everything up into 8 bits, and we're going to store them in 4 different places. Okay, so we're going to store them in 4 different registers, like this. And this is how the register is going to be. Now look, the most significant bit is over here, right? The most significant bit is stored at the lowest address. This is big endian mode. Big endian mode, MSB at the lowest address. Okay, this is big endian mode. Again, MSB at the lowest address. MSB at the lowest address, big endian. Okay, so it goes on in sequence like this. And the address increases 100, 101, 102, 103. So what about little endian mode? Little endian mode is the reverse. Okay, so the MSB actually goes to the largest address. Okay, so 103, 102, 101, and 100. It's the reverse. Okay, and in this class, in this micro-P course, we are going to stick to this mode, little endian. Okay, but frankly, you're not going to see a lot of this. Okay. But just know that you have 2 kinds of storage, big endian and little endian. And you know what's the difference, right? MSB the highest address. Okay, so yeah, as promised, that'll be the end of today's class. Okay, actually we've covered a lot. Actually today, covered a lot. So, right. So today, go back. First thing you do is what? Install that software, and that software is known as the MPLab software. Okay, the software name is MPLab. Make sure you don't download the wrong thing. MPLab. Install them, and I'll post a video on how you configure this MPLab and start writing your programs. Okay, so that's all for today's class. Thank you for coming. See you.